This is your professor, Dr. Lisa English Dowdell. So in this module, we're going to explore the latest trends in web development technologies. We're going to review some web development fundamentals. They're going to be concepts of both the front end and the back end. And then we're going to discuss the roles of PHP and MySQL in web development. Now, for beginners, it's easy to get into web development. There's a lot of languages that are out there that we can use. And once you understand the concept of programming, it's just going to make it a lot easier to make that transition, to other languages. There's a lot of free open source resources, and we're going to be using some of those in this course. Now, the primary language that we're going to be dealing with will be PHP, and we'll deal with a little bit of JavaScript and SQL. Now, because there is so much out there in the way of tools, there's a lot to choose from. But the challenge will be that you'll need to combine a lot of those components together in order to make your website or your web application. You'll need to think about, the UI framework to use, whether you're going to use PHP, Python, React, or maybe some .NET as your coding language. And you're going to have to think about like where you're going to actually store your data. And then you also have to think about like where to host your application. So, we'll try to address a lot of these, within this course. And then you'll also have to consider things like design layout, making your site responsive, addressing any kind of security issues for, say, online commerce or maybe even collecting like private data. Now, this is sort of an ecosystem of what the tools and languages are for front-end development. Now, you might be familiar with some of these. Perhaps you've done some React or some Angular. Maybe you've worked in one of the libraries like Bootstrap. You can use this, sort of like as a map as to what you want to pursue, or learn, for front end. Now, front-end development, also known as UI development, refers to creating web user interfaces. It's the part of the application that the user sees and actually interacts with. Now, front end is what we see when, say, we open a web page or web app. Now, code is downloaded from a server, and then it's rendered to the screen by a web browser. Now, what happens when we interact with code is also considered front end. This is also referred to as the presentation layer or the client, in software development terms. Now, front end development stands firmly on three pillars: HTML for markup, CSS for styling, and then JavaScript for logic and interaction. Now, although these three technologies have kind of stood the test of time, the underlying tools and frameworks change constantly. Now, front-end development is also tightly related to web design and user experience, and the border between the two can be different in each company. Now, front-end developers, they focus on technical issues, while web designers are concerned with maybe the aesthetics and the user experience. So let's talk about some of these specifically. So we'll first discuss HTML. So HTML stands for Hypertext Markup Language. Now HTML, like I said, it's a markup language that allows you to structure the information that is displayed to the user. It's an HTML document that consists of elements, each represented by an HTML tag, such as a heading, a paragraph of text, or text input field. Now, HTML documents can also link to other documents using hyperlinks. Now, each tag carries its own type of content, has a certain appearance, and an attached behavior. Now, HTML5 is the newest version of HTML. And this term refers to two different things. One is the updated HTML language itself, which has new elements and attributes. The second is the largest set of technologies that works with this new version of HTML, like a new video format, which enables us to, say, build out more complex and powerful websites and applications. Now, HTML is used to build out the front end to interact with the back end. So to work with our back end, we're going to be building out HTML pages for this course. So then we have CSS, and CSS stands for Cascading Style Sheets. Now, CSS is a styling language used to describe the visual appearance of the HTML elements. Now, it can be used to control aspects like the positioning of an element, its dimensions, text style, or colors, or almost any other visual aspect, say, of the website. Now, styles are defined as a set of rules that can be applied to a single element of a subset of elements on the page. Now, recent CSS features allow us to go way beyond basic styling and control more complex visual aspects such as animation. Now, if you think of the development of a house or any other type of building, HTML represents the basic structure of the building, the walls, the stairs, the doors, whereas CSS would represent the paint, the decoration, and the styling of the building. Now, while HTML provides your base structure, CSS provides the style of your web page, making it stand out among other web pages on the internet. Now, for CSS, it's a powerful language that has its constraints such as code reuse. So when you're creating something, it may be a challenge to, say, maintain CSS for like a large code-based project. So there are CSS preprocessors that can kind of help with this. Now, a CSS preprocessor, it allows us to define selectors and styles using features that aren't part of the CSS syntax. That are compiled by the preprocessor into something that your browser can understand. So if you want to go into front-end development, you can do a little bit more research into these different ones. You've got your Sass, Less, and Stylus. These are three of the most widely used CSS preprocessors. And these three have similar syntax and features, but also some differences. So Sass stands for Syntactically Awesome Style Sheet, and it extends the capabilities of CSS to make your CSS code more manageable. Now, Sass is completely compatible with all versions of CSS and reduces the repetition of CSS and therefore saves you a lot of time. Sass adds special features such as variables, nested rules, and mix-ins, which allow for like code reuse into like the regular CSS. And the aim is to make the coding process simpler and more efficient. So let's say we have a website with three main colors. Okay, you might need to type the hexadecimal for these colors several times throughout your CSS document. Okay, but instead of typing the value of these, a lot of times, what you do is you use Sass to create a variable to represent these values, and then you refer to the variables. Now, LESS, L-E-S-S, is an acronym for Leaner Style Sheets. Now, LESS is a CSS preprocessor that is like Sass and enables customizable, manageable, and reusable style sheets for your website. Now, LESS is a dynamic style sheet language that extends the capability of CSS. Less is also cross-browser friendly. It uses JavaScript for the manipulation of the values. And it also uses predefined functions to manipulate HTML elements and make changes within different aspects of your style sheet. Now, although being popular in the past, a lot of developers are now moving away from less and in favor of SAS. And then you've got stylus, which is a bit more than a simple preprocessor. It's a language written in JavaScript and running on Node.js and generates CSS. Now, offering built-in functions, support for conditions and logical operators, and a whole host of other features, Stylus has like a flexible syntax which can omit brackets, semicolons, and colons. And it also supports variables, mix-ins, functions, and other features. Now, choosing the best preprocessor for your project is going to be a personal decision based on like your preferences, your experience, and of course the requirements of your project. So you should evaluate the features and the functionality of the different preprocessors, so that you can determine if it meets, say, your particular needs of your project. Now, JavaScript is the most used programming language for developing user interfaces for the web. So it allows you to add custom behavior to your website, such as reacting to user events, loading data from web services, and showing or hiding elements on a page. It also allows you to interact with the browser through various APIs. You can use it at both, add it to add, say, separate interactive elements to your website, or you can use it to create like maybe complex web applications. Now, websites used to be static, no interaction at all. But JavaScript allowed us to, say, create that interaction, like when we're creating games or complex applications or things like that. Now, JavaScript is a powerful language, but if you're looking to make a more complex application, using it without a framework is going to result in masses of complex boilerplate or code. So, in order to make things simpler, there's different frameworks out there that help with the basic functionality, such as like HTML manipulation, data loading, overall application architecture, things like that. The three most popular frameworks now are React, Angular, and then Vue.js. Now, React is not a framework per se, but it's more of a library. It's a library for building user interfaces developed by Facebook. React is based around creating components such as a button or a side menu that can render HTML based on input parameters. Now, Angular is a component oriented framework developed by Google. Now, Angular applications are usually written in TypeScript. So you'll need to learn TypeScript as a primary development language, which makes the initial learning curve a little steeper. It's more difficult to learn, say, than React. And then Vue.js is a framework designed to be modular and incrementally adoptable. You don't have to change everything on your website in order to be able to use it. You can start using it, as a view layer and then add additional libraries, say, as you need them. Now, in contrast to other frameworks, the most important libraries are maintained by the core Vue.js team. Now, there's others out there, but React is the one that I would recommend that you learn first. Now, component libraries are a collection of components that can be used to assemble your application. And some of them implement the most common components such as buttons and drop downs, while others are they provide like utilities for like say creating complex responsive layouts. Now, although each of them has their own distinct visual style, they can usually be customized, say, to match the design and the branding of your project. Now, most of them are available as plain CSS and JavaScript. However, they're often ported to work with other popular JavaScript frameworks. Now, Bootstrap is probably the most popular one. Um, these are used to create, say, responsive websites. Now, Bootstrap is a powerful framework for creating, like I said, those responsive web applications. It comes with like a large set of components as well as utilities for creating layouts and a theming engine. Now, you can add user interaction to components such as drop down, with minimal knowledge of JavaScript. There's also like a wide selection of ready-made website themes built with Bootstrap. Semantic UI is another popular UI library with all kinds of components and a theming engine. However, to make the components interactive, you're expected to write some JavaScript code. And then you've got Material UI. That's a popular implementation of the Google's material design, and it provides a set of components as well as guidelines on how your application should look and feel according to Google. So instead of writing code to create some of these interfaces, you can just integrate Bootstrap. You can edit these to say fit your branding, colors, font, etc. All right, so this is the Bootstrap website, and it has, it comes with really good documentation. All you have to do is download. It tells you how to integrate it within your website. You don't even have to download. You could actually just, if you wanted to just include this line in your website and link to the Bootstrap, the CSS, and the compiled JavaScript code, you can do that. But what I want to show you are some of the components. So let's see. So here it gives you as far as like, how to create like a navigation. It actually gives you the code to this. These are some examples of Bootstrap. And, you can add like your own branding to these. To make them, fit the colors that you want for your website. But rather than you trying to write out all this HTML and things like that, it actually has that information in here. Let me see. I want to go to docs. Okay. Oh, here's an example. Okay, so for instance, like if you were making an accordion, and this is what an accordion. So the website, the Bootstrap website, it talks about what it is. It gives you like how how it's going to work. So here's like an accordion that provides like that accordion feature where, all the content isn't shown at once. It only shows, what the user clicks on as far as that particular accordion item. And then see how it gives you the actual source code here for that HTML. So all you would really have to do is once you embed the CSS within, link to the CSS, either using like the CDN or either downloading it yourself, all you would have to do is put this into a web page, and then it would actually create this accordion here. And there's all kind of different things. So if you wanted to create like a badge, if you want to create a button, some kind of button here. Here's like the different buttons. So in order to create this primary button, and see that hover effect, all you would have to do is include this. So you don't have to write code, to even get that hover effect. You know, all you have to do is just include this within your HTML and put whatever you want the word to be here, and then it changes it there. So these are all the different components. I mean, it has, like I said, several. We had looked at those the nav bar before. So this is a nav example of a nav bar. It actually gives you the code for the nav bar. So that's why, Bootstrap is really powerful, and it doesn't, unlike the other libraries that you have to actually write, your own JavaScript with it. As long as you link to or download the JavaScript that is a part of this library, it does everything for you. Now, the front end ecosystem is known for its large arsenal of helpful tools, each designed for their own, say, purpose. There's a lot of them out there that are designed, if you're going to be getting into like that front end space, then there's some that you might want to investigate. So one is the NPM, and that stands for Node Package Manager. It's a library and a registry for JavaScript software packages. Um, NPM allows you to install libraries that will be used by your project and document them in a JSON file. And you can build out dependencies, run scripts, do testing, etc. Then there's the Webpack, and it's a static module bundle for JavaScript applications, but can bundle CSS, HTML images, and so on and so forth. And it takes all of the code from, say, your applications, and it makes it usable in a web browser. Now, modules are reusable chunks of code. They're built from your app's JavaScript node modules, images, and CSS styles, which are packaged to easily use on your website. Webpacks, they manage dependencies and load code that needs to be loaded first. Now, Webpacks keep track of, say, what files depends on what and loads them accordingly. Now, Webpack can be a little tricky to start with, but it's the cornerstone, say, of most of the modern built setups. Then you have your Chrome Dev Tools, and this gives you a powerful set of tools for inspecting and editing, say, your code. Now, with DevTools, you can quickly find and fix, say, any errors in your code. DevTools lets you measure the performance of your pages. They let you simulate like different types of devices and different browsers. And then with device mode, you can test your page on, say, different devices and see how it looks and performs. The browser mode also lets you simulate, say, different versions of your browser, making sure that your page looks good and functions correctly in all the browsers. Now let's talk about back-end development. So in simpler terms, this is all the things that happen in the background that you visually cannot see. It's mainly code that has to do with functionality and code that is being used to get data, say, from databases. Now we can divide the back end into two parts, the database and scripts. Now some of you might be have some DB experience. In this course, we're going to pick up a little bit more DB experience. We will look at like a relational database in this course. But if you're looking, say, for a non-relational database, you might want to look at maybe MongoDB. Now, for languages, we will look at JavaScript, and we're also going to be looking at PHP. Now, languages that don't require explicit compilation before they execute it, these are called scripting languages or interpreted languages, as opposed to compiled languages. Um, they don't need to produce a binary executable. Rather, the code is evaluated and run, say, on the fly. Sometimes scripting languages are easier to get started with since they don't really, you don't have to write code in a strict manner that is required by the compiler. This, however, does mean that errors could have been could have been, say, discovered during compilation will only become apparent during runtime. Now, some of the other popular scripting languages are JavaScript using the Node.js server-side runtime. It supports its own set of, say, JavaScript features and provides a set of APIs to satisfy back-end use cases such as working with the file system. Now, learning Node.js is going to be a great choice since by learning a single language, you'll be able to work with both on the front end and the back end. Now, Python is another general purpose language, programming language. Its simple syntax and clear constructs make it quite easy to learn, say, for beginners. Now, Python is widely used for developing applications, but also has gained significant traction, say, for doing scientific research and working with artificial intelligence. Then there's PHP, and that's another popular language for web applications. Now, the language itself has a low entry barrier for beginners, but it also provides more advanced features, say, for intermediate users. Some of the most popular projects are created like with PHP, such as like WordPress or Drupal. You know, with the former being argumentatively, the most used content management systems in the world. Then you have Ruby, which is a scripting language designed to be simple and natural to read and write. Now, the most popular development framework for Ruby is Ruby on Rails. And then you also have Jekyll, which is a popular static website generator that's also built on Ruby. Now, code written using a compiled language needs to be first compiled into a binary file before it can be executed. Now, although this needs an explicit extra step to be performed by the developer, it also brings an additional benefit. Now, the compiler can analyze the code for, say, mismatches and give you early feedback about potential problems. Some compilers can also optimize the resulting, say, bytecode for a particular platform, which is ensuring superior performance. Now, these are going to be a little harder to learn. Now, although compiled languages might have a higher entry barrier than, say, scripting languages, they're usually preferable in large projects due to the additional safety measures and more descriptive code. Now, Java is a high-level object-oriented programming language developed by Sun Microsystems and currently maintained by Oracle. Now, Java is designed to be portable between, say, different platforms. The sources are compiled to Java bytecode that can be run on a Java virtual machine for any platform. Now, Java is used to build out so many application types. Java can be used to develop Android applications, now, although the trend in considering Java is kind of old-fashioned and inferior, say, to other JVM languages such as Kotlin, it's still one of the most popular programming languages. Java is extremely popular in the enterprise sector. Then there's C Sharp, which is another high-level object-oriented programming language developed by Microsoft. Now, originally developed to be used on Windows, it can now be used to build cross-platform applications using a relatively .NET Core runtime. Now, one of the most popular frameworks for building web applications using C Sharp is ASP.NET Core. Now, C Sharp is popular among companies, say, adopting Microsoft technology stacks. Then there's Go, and Go was developed by Google, and it's getting more popular. Um, it's supposed to be their version of Java and C Sharp, but it doesn't include like some of the complexity. Kotlin is another closest competitor of Java, and it runs on a Java virtual machine, but compiled with JavaScript. Now, like Java, it can also be used to develop Android applications. Then you have Scala, which is another JVM-based technology, and it's an alternative to Java. It has more concise syntax, additional safety features, and just makes heavy use of functional programming. Then there's Erlang, and that's a functional language designed for concurrency and high availability. Now, Erlang is it's more popular in, say, applications where high performance and scalability is going to be critical. Popular use cases involve image and signal processing or analysis of, say, large amounts of data. And then there's Haskell, which is another functional programming language that is valued for its powerful typing system and a design that helps to produce clearer and reliable code. Now, since it's a functional language, it also scales efficiently and offers like good performance. Now, most websites we see online store content or information in a database. And an important ability of most applications is to store users' data. So it is usually done using a special software called database management systems. Now, database management system or DBMS provides access to underlying data storage, allowing the application to store, retrieve, and update data. And there's different kinds of databases optimized for different shapes and volumes of data. Now, the two most popular types are relational and non-relational. Now, relational databases store data in tables where rows represent entries and columns and attributes. Rows in, say, different tables can be linked using foreign keys to represent relations between like different types of entries. So for example, if you're building an online store, you might have a table for storing orders with the columns such as an order number, a client name, a shipping address, where each row represents like a separate order. And then information about the order's items will be stored, say, in a different table called an order items with references to the order table. Now, most relational databases use a language called Structured Query Language, or SQL, to be able to query or to, say, modify the data. Now, because of this, they often are called SQL databases. We use it to, say, push, store, and retrieve data from the database. So you might refer to this, or you might hear it referred to as like CRUD operations, which represents like create, read, update, and delete. So if we have a form, we might store the values entered by that form into a database. Now, popular relational databases that are used on the web are Oracle, which is a database developed by Oracle. But due to its high scalability and powerful feature set, it's often used maybe more for large enterprises. It's less frequently used for small and mid-sized projects due to, of course, its high license costs. Then you have what's called MySQL, and that's a free open source database developed by a Swedish company. Um, they they're currently though owned by Oracle. MySQL can use different storage engines for each table to store and use differently. Now, MySQL is used for a wide range of cases. However, it's probably most popularly used for like web applications. And then you have SQL Server, often referred to as MS SQL, and this is a database maintained by Microsoft. Now it has different versions or different editions for handling like various different workloads and data volumes. Now SQL Server is a major component, or I should say, their major competitor of Oracle, and it's popular among, say, if you've got like a Microsoft stack. And then there's PostgreSQL, which is also a free open source database developed by a worldwide team of volunteers. And it provides a rich set of features that is capable of handling like large workloads. We're going to be using MySQL in this course. And then these are some of the non-relational databases that you can also look into or that can be utilized. That's MongoDB, Redis, and Elasticsearch. Now, a message broker is a software tool that facilitates services and applications to transfer messages for communication and information exchange. Now, some server-side or say backend operations need to trigger jobs to be executed in the backend, such as generating a business report that might take up some time, say, to generate. And users using this, they don't have to wait for it to show up, say on the screen, because it will handle this in the back end and then send a message to the user that the report is complete. Now, the two most popular message brokers are RabbitMQ and Apache Kafka. Now, message brokers guarantee message delivery in every situation, and the acknowledgement mechanism reports to the producer about the delivery, making the technology highly durable and persistent. Now, the asynchronous processing ensures that the tasks demanding many system resources are entrusted to different processes. And this speeds up your application and improves the user experience. Message brokers redeliver the messages not delivered due to, say, failure. Now, resent is either the resent is either attempted immediately, or say later at some other point in time. Now, if the message remains undelivered after numerous events, then the messages are then rerouted to the producer. Now let's focus on the environment where web applications are run and developed. Now, every platform you develop will have a lot of tools, particularly for that platform. However, there are some that are used by almost all developers. So that's what's represented here. You've used code editors before. I usually use like Visual Studio Code. You also need to get used to a version control system like Git and some other, say, command lines. You also might want to learn some Linux. Now, although you might not work with a networking space, you might want to get, say, somewhat familiar with it. Now, the code editor is the home of every software developer, and this is where the magic happens, okay? Basic code editors provide the most necessary feature lists, such as code highlighting, refactoring, um, debugging capabilities. There are also some more advanced editors, such as integrated development environments or IDEs, that have like a wide range of powerful integrated tools and capabilities. Now, everybody's going to have like their favorite code editor that they're probably most comfortable with. But here are some of probably the most popular ones. So like I said, Visual Studio Code, that's a free cross-platform code editor that's created by Microsoft. And it has built-in support for JavaScript, TypeScript, CSS, and HTML. And has a lot of support for a lot of other languages that are available as extensions. Now, VS Code offers syntax highlighting, code completion, code snippets for generating code, refactoring capabilities, and a built-in terminal. It also has an integrated debugger that's going to help you troubleshoot like bugs in your application. Now, although the feature might not be as say wide as usually as in like the commercial like IDEs, it's basically enough to get you started. Now, there's also Sublime and Notepad++, and these are also some really good editors as well, and they're free to download and to install on your computer. Now, version control systems play a key role in every development process. We refer to them as VCS. These allow you to store a complete history of all your code changes in a remote repository. You can browse the repository to review the change history, compare different versions, or say even roll back to like maybe an earlier version. Multiple developers can push changes to the same repository to say collaborate on a project, keeping like their local code bases in sync. Now, nowadays, they're used as the ultimate source of truth for the code base and are, say, the backbone of modern development processes. Now, these VCS systems, they can be used via command line interface, but they're also used, say, using different like GUI clients that are available, as well as integration with, say, different code editors. Now, Git is the most popular version control, and it is by far, say, the most popular VCS. It's a distributed system, meaning that when a user copies the repository, they'll get the full history of the project that can work, and they can work with it, like say, offline. Now, occasionally, users need to publish their changes to the central remote repository and then download changes made by others. There's other services providing like host Git repositories, but the most popular one of them is the GitHub or Bitbucket. Now, let's talk about the actual development and programming process. So, an algorithm is a step-by-step set of procedures, of how we would actually program. They're used in IT to design programs, and it's good practice to write an algorithm first. Now, here are some of the main symbols that we use. So in Word, these are included in the Insert Shape flowchart section if you ever want to create these. Now, the main symbols are the parallelogram for input and output of data, like keyboard, or read from the database, or print to screen, etc. The rectangle is used for processing like, you know, changing image names or checking variables or making matches and things like that. So this is an example of an algorithm flowchart. So we start here, our user would enter the website, they would go to the home page, they would enter the email ID and password, and then a decision will be made. Is the email ID and password correct? If yes, then display the account information and stop. But if no, then log an error, and then we'll allow the user to enter the email ID and password. So this kind of writing this out gives you an idea of how you're going to actually program your application. So this is why this is the first step, so that you can visually see, how you're going to actually write your program. Another way that we can plan out our program is using pseudocode. Now, pseudocode is an outline of a program written in plain English, which can really be converted or easily converted into real programming statements, at a later time. Now, pseudocode, of course, it cannot be executed to run, but it's basically intended for human reading. Now, before writing code, developers often use algorithms and pseudocodes to, say, plan their logic. And these tools help to break down complex tasks into smaller and manageable steps. It also helps to visualize, like I said, the flow of the application, and it will reduce errors during coding. Now, for example, if we were to design, say, again, that login system that we saw, the pseudocode might look something like, prompt user for username and password, check database for matching credentials, if the credentials match, grant access, otherwise display an error message. Now, this logical outline, it's going to make it a lot easier, like I said, to be able to translate this into actual code at a later time. Now, another thing that we need to do before we actually start coding is we need to kind of plan our layout. You know, this is visual. We're creating web applications or websites, and so it's a visual thing. So this is where wireframing comes in. Now, wireframing is like creating a blueprint for a house. It helps us to visualize the structure and the layout of our application. Now, some of the benefits of wireframing is that it clarifies our ideas and ensures that everybody's on the same team, and that they're all on the same page. We're all visualizing the same thing. It also identifies potential issues early, saving time, say, during development, and it provides a visual guide for developers and for designers. Now, there's a lot of tools out there that can be used for wireframing. One is Figma, which is a popular tool for creating like digital wireframes. You can also use Adobe XD, which offers like advanced design features. Um, and then there's, you know, things like you can actually do sketches doing like pen and paper. Mock-ups is one that we'll be using for this course. Or you can even use PowerPoint. Like for instance, here's an example, of say a simple wireframe for a login page. Notice how it has like the placeholders for like the username, the password field, and say a sign in button. Now, for web application projects, your wireframes, when you do your wireframes, they might include like basic pages. You may create wireframes for like whatever your homepage is going to look like, your layout. You'll create a layout for your login page, perhaps, maybe your registration page. Just remember that good planning is going to always lead to better results.